Problem 17 was the one where you have to insert either the equal sign, the less than sign, or the greater than sign in order to make each statement true. So let's look at part A. You have a 13 plus a negative 30, and then a negative 30 plus a 13. So let's do the one on the left first, okay? So we are going to be adding two numbers with different signs. One is a positive and one is a negative. So when we are adding numbers with different signs, our adding integers rules say that we subtract the numbers and keep the sign of the larger one. So in this case, our 30 minus 13, 10 minus 3 is 7, 2 minus 1 is 1. So our number that would come out there is 17, and then we'd keep the sign of the larger one, which in this case is this negative sign. So I would have a negative 17 on the left side. On the right side, we are doing basically the exact same thing. We are taking the negative 30, adding it to a positive 13. So we already did this calculation. It comes up with a 17, and you keep the sign of the larger number, which again in this case is negative 30. So the sign you should have written in the box for part A is the equal sign. Part B, you have a 9 minus a negative 11, and then a negative 11 minus 9. All right, let's look at the left side first. So a 9 minus a negative 11. This is a subtraction problem. So we can add a line and change the sign. Again, you don't do anything to the first number, just the last ones. So now you have a 9 plus a positive 11. They have the same sign. So you are just going to add them and keep the original sign. So in this case, it was positive. So the answer for the left side is going to be 20. Let's look at the right one. So on the right side, you have a negative 11 minus 9. Again, this is subtraction. You can add a line and change the sign. Even though the 9 is not originally negative, it doesn't have that original sign to change, you still do change the sign from positive to negative. Now you have a negative 11 plus a negative 9. So again, we do have numbers that have the same sign. So you're going to add the numbers to get 20, and then you keep the original sign. In this case, the original sign before you did that addition is subtraction. So on the right side, you'll have a negative 20. So for part B, you should have written the greater than sign. This is an excellent example. So if you notice from part A, you could flip the order, and since it was addition, it would not matter. It would not change the answer. Here, if you switch places of these two numbers, it does make a difference. It actually makes a very big difference. That is because subtraction is not commutative. The commutative property says that you can do something in either direction and it does not matter. Subtraction is not commutative. Moving on to part C now, we have a negative 4 times 3. Remember, that is a multiplication. Compared to a 3 times negative 4. So with multiplication, we can ignore the signs, do the multiplication like normal, and then re-enter the signs later. So we have a 4 times a 3, that's going to be 12. And then we're going to look back at the signs. I have 1 negative and 1 positive. So I'm multiplying things with different signs, which means my final answer is going to be negative. When you multiply or divide numbers with different signs, so different signs, your answer is going to be negative. When you multiply or divide numbers with the same sign, your answer will be positive. Looking at the right side now, you have a 3 times the negative 4. Again, you can ignore the sign, do your multiplication like you normally would. 3 times 4 is going to be equal to 12. You look back and you notice that you have 1 positive and 1 negative. So again, your final answer is going to be negative. So for part C, you should have written an equal sign. This is to show that multiplication is commutative. So that means you can do it in either direction and it does not change the value of the answer. You can switch the numbers, the order of the numbers, and it doesn't make a difference. And finally, we have part D. We have a negative 20 divided by a negative 5 compared to a negative 5 divided by a negative 20. All right, per usual, we can ignore the signs at first and do our division like normal. So in this case, it's 20 divided by 5. Make sure you're putting the correct number underneath the little division house. The number that goes inside the division house always comes first. The first number in a division problem is what will go inside. Okay, so make sure you're setting it up correctly. So 5 does not go into 2, but 5 does go into 24 times because 4 times 5 is 20. We subtract that, you get a remainder of 0. So I know 4 is my answer, or this quotient. Now I have to look back at the signs. I have 1 negative, and then I have another negative. So since I am dividing numbers with the same sign, my answer is going to be positive. So on the left side, I have a positive 20. Now let's look at what's on the right side. So on the right side, we have, again, we're ignoring the signs. We have a 5 divided by 20. Yes, 5 divided by 20. The number that is in front is the number that goes inside. Okay? So these two statements are not necessarily the same. On the first one, the 20 was in the house. Second one, the 5 is in the house. All right, so with this, though, 20 does not go into 5, so you have to do the whole add a decimal and a 0 thing. 20 goes into 50 twice, because 20 times 2 is 40. You get 10, but unfortunately, 20 does not go in to 10. So you have to add another 0, bring it down, 100. 20 goes into 100 5 times, because 5 times 20 is 100. We subtract that, get a remainder of 0. So in similar problems, when we've done this, see this little decimal point? You're going to treat it like a rubber ducky. It pops straight up like it would out of the water in a bathtub. So my final answer over here, so my quotient was 0.25, but my final answer depends on the sign. So I have one negative, and I have another negative. So that means when I am dividing numbers with the same sign, my answer is going to be positive. So my answer for the right is a 0.25. Again, I like to put that 0 in front of that decimal point just to highlight the decimal point. I'm outlining this so we don't lose it in all this lovely mess of division. Okay, so when I am comparing these, it's very clear 20 is clearly greater than 0.25. So this part was an excellent example of how division is not commutative. Okay? So moving forward from this problem, all I really want you to remember is that in order for something to be commutative, you must be able to do it either direction. You must be able to switch around the numbers and have it not change the ending answer. Addition and multiplication are commutative. Subtraction and division are not. That means, like if I have 2 times 3, that is the same as 3 times 2. But if I have 3 minus 2, that is not the same as 2 minus 3.